Welcome to this inLab Software 15 tutorial. This video covers the complete workflow to produce a CEREC Guide 2 surgical guide. First, you will learn how the laboratory designs the desired restoration. The second part of the video leads through the exact implant planning in the clinic with the help of a DVT file. The final sequence explains the production of the surgical guide in the dental laboratory. To produce a CEREC Guide 2 surgical guide, you first need the initial situation, meaning the jaw situation without implants. You now want to design a bridge on this model that should then correspond with the situation of the final restoration. There are two options for this. The first is to take a normal impression in the mouth and scan it with the INEOS X5. The other is for the dentist to use the OmniCam, as in this case, or another intraoral camera to scan the situation in the mouth and send it via Sirona Connect to the inLab software. A 4-unit bridge is created in the administration section. Then select your milling unit and the material as usual. In this case, it does not matter which milling unit and what material you select, because you are not going to mill, only design, and then send the result to the dentist. Set the model axis as usual and indicate the jaw ridgeline. Then go to Trimming and enter the preparation margin. In this case, the dentist has already marked the preparation margins before sending the data. Next, go to the insertion axis and set it as usual for a bridge. After choosing the morphology, you will receive a positioning proposal. In this case, the gap is somewhat smaller, so we attempt to make the teeth slightly smaller to be able to position them. At this point, you place the teeth according to the desired final restoration, so the implant positions can be defined in the next step. The height of the individual elements can also be adjusted. The bite situation is very unusual in this case. However, thanks to the many adjustment options of the inLab Software 15, this is not a problem. Then the opposing bite is checked and the positioning is further improved. When pre-positioning is completed, the proposal can be calculated. This can be done in the non-adapted version. The case involves only an accurate implant positioning to be able to design a precise surgical guide. The final design of the bridge can be postponed at this point. It is useful to focus on the exact positioning of the restoration and leave the details for later. In the last step, the bridge is exported via the top bar using Export. The bridge is saved as an SSI file for GALILEOS and can be sent directly to the dentist, for example via Sirona Connect. In practice, the dentist combines the data for the bridge with the patient's X-ray images for further processing. In order to construct an implant-borne bridge, you firstly require a CBCT and a construction of a restoration based on a model or an intraoral scan. The restoration and the model are matched with the CBCT. Now, search for the corresponding file, which must be available in SSI format. You can see a preview here. Click on Next to view the CBCT and the virtual model. Now, specify the relevant marking points on both that the software is to use to superimpose the X-ray scan and the 3D model. At least 3 points must be specified. On pressing Next, the two images are superimposed. The superimposition is shown again here to allow checking. If you are satisfied, accept the calculation by pressing Confirm. You are now taken to the actual construction mode and can select the implant by pressing the New button. In this case, it is a Camlog implant 3.8 at position 2-3. For an initial assessment of the situation, you can firstly virtually place the implant roughly where it is to be subsequently positioned. Then align the implant. For this, change to the implant-aligned position and position it according to your requirements. Once the initial implant alignment is complete, position the sleeve for the corresponding drill key. To do this, go to Sleeve. The following is already selected at the top: CEREC Guide Drill Keys. Select the relevant sleeve and set the sleeve position according to the implant position. Watch on the screen as the sleeve position moves parallel. The sleeve should be slightly above or on the gingival level or just below the gingiva. This decision is to be made by the planner or subsequent surgeon. To plan another implant, click on Add Implant. This is a 4.3 and also 11 mm Camlog. Select the position, in this case it is 2-6, then select OK and position the implant roughly at position 2-6. As you are again in the implant-aligned view, you can see the implant in the jaw and can now align it to suit your needs. Again, here the sleeve must firstly be specified. Select the right sleeve. In this case, it is the small sleeve. You can now align this so that it is slightly epigingival or subgingival. To align the implants as parallel as possible, one of the implants is activated and aligned so that it is parallel to the other implant. Correct both implants to ensure that they are as parallel as possible to avoid additional corrective work in the abutment area on the subsequent prosthetic restoration. Yet, as you can see here, despite alignment, significantly angled abutments will be necessary here. The 3D view allows you to check parallelism to a certain degree. In this case, parallelism exists. You can also see that the implant at 2-3 is outside the planning. You should try here to push the relevant implant further inwards. In cases which are as difficult as this can be achieved by inclining to enable the subsequently desired construction. Check the sleeve positions on the implants again and adapt these to the changed implant positions. The sleeve position is also checked again on the second implant. In this case, implant 2-3 is relatively high. For this reason, the implant should be moved down slightly. This is doubly true bearing in mind that bone augmentation may be necessary in this area. Accordingly, the sleeve should be corrected again should it still be too high. The implant planning is then exported. The Plan tab offers a number of options. You can, for example, generate a planning report on paper. This is expedient if other surgeons are to perform implantation. The drilling template can also be ordered here. To this end, this window opens. You can select Export to third-party suppliers here accordingly. The specified implants, length, key, and sleeve positions are then shown. The directory to which this file is to be exported is selected in the lower area. If you have selected this directory, confirm by pressing Export. You are shown a message stating that the file was successfully exported to the corresponding folder. Planning in the Galaxus software is now complete. You can now, for example, transfer the file to the laboratory which uses this data to prepare the drilling template. When the dentist has finished planning, he returns the file via Internet, FTP upload, or email. You can then import the file into the software via the Import button here at the top. This is a cmg.dxd file. It is opened, and the indication field Restoration Type Implant is also displayed here, which is not visible otherwise. You now have the option of producing the surgical guide on two different milling units. This can be done using the MCXL or with the MCX5. You can place only one implant in the MCXL. In this case, where you want to place more than one implant in one surgical guide, the MCX5 is the right milling unit and is activated. This means that when I mill a surgical guide with the MCXL, I can use it for only one implant. If you want to produce a surgical guide for more than one implant, you have to use the MCX5. Now, click on this milling unit and select the material PMMA guide. Then, go to the model phase. In the model phase, the model axis must first be adjusted. All values must be set so they are identical to the values in the basic module of the inLab 15 software. Next, the application range is determined. This means that you define the size of our surgical guide here. It's enough if you design it up to the area of the central incisors. You can adapt the surgical guide according to your needs. Since the impression of the second and third molar is not exact, the guide is reduced in these areas. Next, go to the direction of insertion. The direction of insertion is used to block out the model and the undercuts according to your design. Here it is important to create the largest possible contact surfaces on the teeth so the surgical guide fits securely without shifting. Continue and set the thickness of the guide and the spacer here in the parameters. We recommend setting 2 mm as the thickness of the plate. Of course, you can also make the plate thicker. The preset spacer of 60 microns has proved to be suitable. Continue to add the drill key. You now receive the warning that the drill sleeves will penetrate the preparation. This means that the drill sleeve would penetrate into the gums here. So if you don't use the flap surgery method and make what is called a punch, this would cause discomfort. You can process this support. This can be done here in grind support or retain support. In this case, we want to grind the support. This is shown in green on the model. The places that are visible below the gum line must be removed. You can also decide whether to grind or retain the second support. In this second case, the support is retained in order to demonstrate the consequence of this decision. Green is displayed again, and you can continue. In the next step, the size of the support is defined, so the support does not disturb the adjacent teeth. You need to work very precisely so that the dentist's drill sleeve has an accurate fit. In the next phase, the CEREC guide is calculated. The surgical guide is calculated and its position in the disc is displayed on the screen. Now, go to the step Inspection window. You can now see that the drill sleeve no longer penetrates the gums on the side where the support was ground out. On the other side, the drill key sleeve is penetrating the model. This illustrates the importance of precisely adapting the support to the jaw situation. In the next step, add an inspection window. We recommend positioning the inspection window near the support for the drill sleeves. The fit of the guide can be checked precisely here. Of course, you can place the window at another location if desired and double-click to confirm. When you are satisfied, click OK and continue to edit the surgical guide. In this step, the surgical guide can be cut out more, meaning adapted to the teeth if you or the dentist wish to do so. You can also still process the edges using the Form tool. Of course, you can also mill the guide at this point and straighten the edges later. The supports that will later hold the drill sleeves cannot be edited. This is to ensure the proper fit of the drill sleeves for inserting the implants. Then you can go to the production step to send the data set to the CAM software. Thank you for watching. We wish you lots of success working with the inLab Software 15.